Okay, before let's start. So this time you are visiting Tokyo for about 1 month, and nearly at the end of your stay, you are giving a colloquium lecture today. And before that, we ask you something mostly for students. Mm-hmm. Yeah. And okay, so let's start. So maybe so we start from before you enter the university. So how you got interested in mathematics?
Mm-hmm. So first of all, it has been a wonderful month in Tokyo as usual. So and it's a great pleasure to come to collaborate with colleagues and to visit other cities. This time I visited Toyama. So about my beginning as a mathematician, how I was initiated to mathematics, in fact, nothing original. I was initiated by my father, who is a professor, high school professor of mathematics. He put me on the track of this kind of competition in mathematics early. So I got a small success locally, and then I was selected for national level. And this has led me to the International Olympiad, which was maybe a kind of milestone in my education. So, by the way, I remember that I was 18 at the time, and I participated to the Olympiad in Australia. And this was my first time to leave Tunisia, to leave Africa. And I got a very long flight at the time. Like now, we have to travel through the North Pole. And I landed in Narita for the first time. So this was fascinating for me. I also met a lot of young people.
This is just for connection.
Sorry?
At Narita.
Yeah, it's just for connection. I at the time I did not know that I will come back, or it will be a kind of my permanent destination in some sense. So anyway, this has led me to meet some very nice people. Some of them became friends, like Ngo Bao Cho. I remember also.
You were there at the same time.
Yes. So I remember also. Terence Tao, who was 13 at the time, just very young, but very, very talented from the beginning. Yeah. So this is mainly the beginning. So after that, I went to France.
But before going to the Olympic game, maybe there was some reason or something how you got interested in mathematics.
Probably it's not really very original. As I told you, it's maybe the influence of my father.
Oh yeah. So he taught you himself?
Not really, but we spoke about math. Like I remember we go to the same high school. He teach at the time. He was also even the kind of head of the high school. But we took the car every morning, so I go with him. And during these trips, we discuss a little bit about math. So he was always trying to introduce me to some notions which we don't get in high school, and it excites me. So, for instance, he explained to me for the first time what is a group in the car. So I remember this, and in some sense it was a kind of challenge for me to just follow, and then I got a little bit more excited about it. And so in the beginning,
at high school you studied mathematics by yourself, or somebody taught you?
But in fact, it's a little bit a mixture. So I was following the usual program. So, but for this kind of advanced things, I was doing things by myself before getting a national coach. But this was later. In the beginning, I was doing it by myself. But I was, for instance, fascinated by Euclidean geometry. Problems of Euclidean geometry, and I remember that in my year they changed the program. I was the first generation of a new program in high school, which was where the geometry level was very high, so they put a lot of geometry. So this took, maybe it stayed like this for 5 or 7 years, and then they changed it. It was too much. But it was for me exciting, and even some professors were not able to solve the problems proposed in the book. So I was a kind of fascinated because I can do things that they cannot do.
Yeah.
So, but yeah, in some sense, it was really in the beginning kind of challenge for a kind of teenager. You feel that you are able to do these kind of things, and it's nice. But yeah, the true taste of mathematics I got it much later, in some sense, when I went to France.
Yeah. So to enter the university, you moved to France.
Yes, after the end of the high school. So this is the usual, in some sense, way for students from former colonies from France, North Africa. So the best go to France to study. So I went to the classe préparatoire, which is the French usual system to train in mathematics.
So, maybe now you can tell me how you studied mathematics as a student.
Yeah, so there were different phases. So the first phase was a kind of continuation of this challenge of a high school. Anyway, it was take place in a high school, Louis-le-Grand. So the thing which in that phase, maybe the challenges were mixed, both to adapt to the French culture and to meet the required standard, because it's very selective. But I was successful because of the preparation to Olympiad. So in some sense, I don't keep a kind of wonderful mathematical souvenirs of that period. Then I entered the École Normale, and I remember also one discussion with one student 1 year older than me, who for the first time told me about algebraic geometry. I was not a kind of know things much before I was introduced to them. I heard about algebraic geometry, but I was not really at the time before this discussion with this student, fascinated by it. So, like all students of École Normale, I got interested in the Grothendieck as a person, as this kind of a new basis of algebraic geometry that he introduced, and the whole French school. So then I decided to move to Orsay. So I was still student of École Normale, but I decided that I should go to Orsay. And it's in Orsay that I really fall in love with algebraic geometry. So I discovered that there are really fascinating things. Before, in some sense, I know that there are some topics that I am not ready to do, like analysis. I don't like too much, but I was open to many things. So the fact that algebraic geometry became a kind of natural, tautological thing that I have to study came after I went to Orsay.
So at the time at Orsay, there's a very strong group of algebraic geometers.
Yes, it was fascinating.
So you are influenced by some particular professor or your colleague or? Yes, definitely. There is one person who played a fundamental role in my education and my training as a mathematician, Michel Reynaud. But I did not encounter him from the first time. So first I was a student. I did my PhD with Lucien Spiro. He was interested in oracle of geometry at the time. I got also a wonderful, in some sense, contact with Guy Enyart, who was a professor, and he taught class field theory. So I loved a lot his course, his wonderful style, precision. And then I started working on oracle of geometry. So, I remember that the precise time where I met Reynaud. So I know who is Reynaud, that he was a great mathematician, probably one of the best algebraic geometers on the world. And
both, but he was not giving a course that year, so there is no reason for me to, in some sense, get in contact with him. But I remember that I was going to lunch with a friend, Emmanuel Ulmo, that you know very well, and we were discussing about things that we use in oracle of geometry. And in oracle of geometry, we use some tools of algebraic geometry, but at least at the time what I was doing, I was not investing too much in the algebraic geometry aspect of these tools. And we wanted to use them on the boundary of what is possible. So we got confused about, if I remember well, about something about dualizing sheaves. And we encountered Reno in this small way in the forest from Bâtiment 425 to the restaurant, if you remember.
Yes, the slope.
Exactly, so this slope. So he go often early to lunch, and so we asked him. So I asked him, what is, how can we, in some sense, see things? So he gave us. It was me and Emmanuel. He gave us an answer in 2 or 3 sentences, which suddenly make things so clear. While it's always confusing in the books, it's so confusing. I said, how this happened? How someone can be so clear in just 2 or 3 sentences? This is where I have to go. And in fact, this is make that as soon as I finished my PhD, I shifted in some sense inside algebraic geometry to a more geometric aspect and to things which are closer to him.
I see. So Michel Reno gave very strong influence.
Then I got close from him. I got a lot of discussion with him, in particular about things that we did together, ramification theory, which he liked a lot. Yes.
I see. So other than this, you have some souvenir from your student time?
Souvenirs from... there are a lot of souvenirs. Some of them maybe are not... some of them are not very good. So they reflect a little bit my ambiguous relation with France, a country that fascinates me and from where I feel very close, but at the same time where I feel a little bit sometimes in a kind of small conflict. Good souvenirs, I think precisely the best souvenirs are the encounters. So even with Michel Reno, I have got several encounters. So another encounter is we wrote a paper with Emmanuel Ulmo and about the Manin constant, and Reno has done something about it, which is mentioned in many articles. So we wanted that he give us the letter which is mentioned, but to just see it and study it. So we gave him our paper, and we asked if he could give us his letter to read it. He took 2 days and then asked us to come. And then I remember he put me in his seat in his office, and Emmanuel stayed near in another seat. And then he went to the blackboard, and he said, "Okay, let me explain to you what you proved." And he started explaining what is in our paper in his way. It was fascinating. So, and then he said, "Okay, this is nice. It's a new idea, but you have to write it like this. And I'm willing to give you my letter, which people mentioned but never diffuse in some sense. But I ask you to publish it as an appendix of your letter, of your article." So this was the first, in some sense, a little bit more advanced exchange with Michel. So what else? So this is from my study in some sense times. But later there was some very important encounters. In particular, an encounter that started our collaboration between both of us. So I think it was at EHP. I remember also another funny souvenir with Luc Luzy. So but luckily it took some time before I got close from him, precisely because Luc is not interested in oracle of geometry, which I understand. So, and he knows that I work on oracle of geometry. And then I moved to Paris Nord, I got my first position. And it was the time that I decided to shift completely. And I started working on Bldg paper, on the conductor formula. And so I proved some result. And the CNRS decided at that year regularly to evaluate the laboratory. And usually when there is an evaluation, they make a kind of half a day with lectures, usually with young people that just arrived to the lab as a young researcher. And the committee attend these short lectures and then do some interviews with all people. And it turns out that the CNRS choose Luc as a representative to evaluate our component, which is arithmetic geometry. So Luc came. He told me afterwards, because this was our really first true encounter that make us close to each other. So he told me that he was very afraid coming to Paris Nord to listen to a lecture. He knows that I will give a small lecture, to listen a lecture to oracle of geometry. And then I started speaking about vanishing cycles and block conductor formula. And he was so happy.
It's exactly his subject.
So this was also very nice. So from that time, I became close from Luc, and then I came with him to Japan several times. These are nice souvenirs.
I see, Okay. So now, after this, you give talk at Tokyo, but maybe you can give some idea what you are studying as a researcher. Maybe for
in general, or about what I will speak in the colloquium? In general. So I am doing arithmetic geometry. So arithmetic geometry means a kind of combination between number theory and algebraic geometry. So I am more on the side of algebraic geometry than number theory. And in fact, I have been doing two things. Maybe this is something which is clear for us from inside, but not clear for the people from outside. So there is exactly. So there are two prime numbers for arithmetic geometers. There is P and L. So I was doing L-adic theory, and now I am doing more p-adic theory. So I am mainly interested in the study of sheaves on algebraic varieties. So these sheaves could be L-adic or p-adic, so I'm interested in computing their cohomology, in studying their invariance, so in constructing classification, like describing them. So it's complicated to describe what is a sheaf in, In fact, so this year I was thinking a little bit about this notion. And I have to explain it to people that do not know at all what is a sheaf. So, in fact, in a very different context, I found that the best way to speak about it was to tell them about the beginning by Leray, how it came. Like it's a kind of a notion born from struggling, from resisting, in a prisoner camp. So in any case, I feel close from sheaf theory, maybe because of that, because I like struggling and I like resisting. So, but anyway, sheaves are close from, in some sense, maybe the easiest thing to see it are representations of the fundamental groups of variety. Or you can start even with the representation of a Galois group of a field. So this is can be seen as a sheaf for a certain topology. But there are sheaves of various types. There are some coherent sheaves, there are some discrete sheaves, some differential modules or sheaves. So I like all of sheaves. I do not. So definitely the differential sheaves are maybe the sheaves that I studied the less, but I encounter them more and more in p-adic. So I like L-adic and say p-adic etal sheaves.
So before asking the last question, so let me ask one more. So you visited Japan for many times. So you now you met some of students here. So for your opinion, what you see some difference between students in France and students in Japan?
Oh yeah. Definitely. So in fact, I know students in France. I know also students in China. In the beginning of my career, I also get in contact with many students in the US, and I know the students in Japan. So maybe the most characteristic aspect of the students in Japan is that they are shy. They are extremely shy, so it's not easy to get in contact with them when they are students. Many of them became colleagues and even close friends when they became young researchers. But when they were doing their PhD, I don't remember too much that I got involved in any of their work. I can discuss some time with them, with very few of them. Usually they give wonderful lectures. I attend the seminars by them. So, but I feel it's a little bit something difficult to enter. While in China, I really went much less than Japan, and I got involved very quickly in forming students. So I got PhD students from China, both in China and in France. So was so, but probably Japan do not need people from abroad to form, because you have a wonderful school. I think it's more related to the fact that students are very shy. So, and from this aspect, I think it's very important for students in Japan to travel. So I was very happy to welcome some of them at IHES. So, so I think this aspect is definitely very, very important. So beside that, definitely the research they do is the top level, because they are formed by the best schools. So there is nothing to say. So nothing to say.
Okay, then to close this interview, can you give some message to students who just started mathematics or who want to start now? Some words? So maybe advices to more advanced students or really undergrad students, or which level? Both? Yeah, the beginners.
Beginners. So in some sense, maybe from my experience, the most important aspect is the encounters we do in mathematics. So in the beginning, we think that it's a kind of a very individual task. In some sense, there is definitely a big individual part of research, but it's a path we don't do alone, and it's a path that we do with others. And I would say that the success depends, in many cases, there are definitely some special people that can do alone, by themselves, exceptional things. But the success of a career depends a lot on the encounters we get. So it could be a mixture of opportunities, like, for instance, encountering Renault in my way to. So it could be meeting someone in a conference that you did not expect, but it could be also that you can look for, try to contact, do an effort to contact someone. And definitely life, the mathematical life can change after meeting someone. So, I know this, for instance, the fact that I come often here to Japan, it's in big part because of the collaboration we started. So at the time when we started our collaboration, I think it was 99.
Yeah.
Yeah, so you were much more advanced than I was just beginning in ramification theory, a theory which was not really developed in France, though there have been many important people that did it before, like Brylensky, Verdier.
Yeah.
But at the time I was working, I was alone. And I met you. So then, discovered that I have to come to Japan, and this was a beginning of a wonderful, wonderful experience.
Yeah, thank you. So thank you very much for interesting you and very valuable message to students. Yeah, thank you very much.
Thank you very much. Thank you.